Okay, welcome everybody. Welcome to the show. Mr. Viteri here. So we are continuing our conversation on renewable and non-renewable resources. And yesterday we talked about trends that have happened over time, where coal was primarily our energy source in the 1800s. Previous to that was biomass, which would include trees, uh, wood, cow manure, things like that. And then we transitioned, and petroleum is basically where it's at this point. Natural gas is second to that, and coal, or all three of the fossil fuels, are still used more than nuclear as well as renewables. We are trying to move towards more renewables, but until that time comes, we'll just learn of the energy types that we're currently using. So let's really focus on coal. It's on our CED, course, an exam description, and you may want to know what it is. And I mean, a silly understanding of it is fossil fuels. When we think of fossils, we think of dinosaurs. And when we think of dinosaurs, we think of dinosaur bones. And so sometimes you may think that coal or oil or natural gas, petroleum, is basically made out of bones. Well, typically not necessarily. Coal is going to be made out of organic material. Organic material primarily is carbon. That's a reoccurring theme. We are mostly carbon. Carbon is the basis of all organic living things. Well, now I want you to imagine areas that are very, very rich in carbon. That'll include like wetland areas, swamp areas, forests, things that have a lot of carbon. And over the course of history, sometimes storms could happen, earthquakes could happen, whatever happens, large fires, dust storms, volcanic activity, a large portion of land, biomass, is going to be trapped underground. And after an immense amount of pressure, and as it gets deeper into the Earth's crust, it gets warmer and warmer. And after layers upon layers of sediment built on top of these things, that organic material is going to now solidify and become coal. It could become oil, it could become natural gas as well. So, as we today, we're going to focus on coal. There are different grades of coal, if you will. There is better coal and there's worse coal. What's the difference between the two? One produces less um, pollution than the other, because the one that produces more pollutants has more impurities. You can think of it like a diamond. I remember buying a diamond for my wife, and one of the things that you want to look at is the clarity of the diamond. And what does that mean? Well, you could look at the diamond, and if a diamond is clear, it doesn't have any specks in it, black specks, which would be impurities, then your diamond is, oh, I don't think they use grade A, but there's a different grade. I'm just not remembering it. But the clearer it is, the clarity it is, the more valuable it is. You can think of a coal like that too. The less impurities it has, the more valuable it is, because it's going to produce less toxins in its when it is ignited. So let's just talk about all coals, and then we'll talk about the different grades of coal. And so, very early off, when this organic material is heat and pressurized, look at this. This is beautiful. As more heat and pressure forms, the better coal. This would be the best coal, anthracite, and not necessarily a coal, but the starting block for coal is peat. This would be the early start. Then we could also say increasing in moisture as well. So this would be a lot of moisture. Anthracite would have no moisture. Moisture is going to produce a lot of smoke. So anthracite, being least amount of moisture, is not going to produce a lot of that black smoke that we would see. If you were burning leaves or something, you would notice that there's a lot of black smoke because there's a lot of moisture in leaves. So here, what's the difference between peat, lignite, bituminous, and anthracite is going to be, as you increase heat and pressure, then the more pure coal is going to form, which is called anthracite. All right. Peat would be the parent material. It all can become anthracite depending on when you find the material, depending on your geographic location. Uh, United States has coal reserves. Russia has an immense amount of coal reserves, and so does China. China has a lot of coal reserves as well. Uh, so, depending on your, in the United States, we try. Coal has a bad reputation because it is primarily going to cause acid rain. So we try to stay away from coal, and no one really wants to have all that black smoke in the atmosphere as well. So we tend to shy away from coal. China, on the other hand, uses a lot of their power plants are coal burning power plants. The power plants in the United States are they used to be coal. They're transitioned to natural gas at this particular point. I believe in Seymour, we have a natural gas power plant. In Elizabeth, New Jersey, also natural gas. I think there is one of them that has a cogeneration system where there is coal and natural gas. But once again, coal is getting a bad rap. Um, I know there has been some talk of clean coal technology. What does that mean? Well, it's a way of sequestering the exhaust. So imagine you're burning that coal, the exhaust pipes are going out into the atmosphere. Well, if you could take that pipe and then put it back into the ground, what? Yeah, pump it back into the ground can store carbon. Surprisingly, oceans store a lot of carbon, and the soil can and store a lot of carbon as well. So that's what they're trying to do and develop these clean coal technologies. To me, I don't necessarily quite understand it because if you pump the gas into the ground, how does it necessarily stay there? Couldn't just seep out in other places? But um, there are smarter people than me. But that's it in a nutshell. Or other technologies can use to trap the exhaust from those exhaust pipes that are going to leave the power plants. Okay, so you're going to have to remember these in order from cleanest to the worst. And it's in alphabetical order, so it's not that bad. What kind of alphabetical order? Let's look at this. Anthracite is the best. A, first in the alphabet. Then we have bituminous. We have two bituminouses. We have bituminous and subbituminous. Okay. And then finally, we have lignite. So those are the four different grades of coal. The price difference would be the most expensive anthracite, the least expensive lignite. Peat necessarily is not a type of coal. However, some places do use peat for an energy source, and it would be like a swamp or bog. I've seen them do this in Ireland and Scotland. A swamp or bog, and they actually just cut out a piece of like topsoil. It looks like topsoil, but it's really just dense vegetative matter, which we call peat. It's going to produce a lot of smoke, but people need to keep warm. People need to cook food, and this is an energy source that they can use. Of course, we would all want renewables, but sometimes it's not necessarily possible. Okay, so you can pause this and make sure that you're going to remember anthracite, bituminous, subbituminous, and lignite. All that are the different grades of coal. How are they different? Well, anthracite takes the longest and the most amount of pressure to form, and lignite is going to come from peat as well. They all come from peat, but it's not as pressurized, so it has a lot more moisture in it, and that moisture leads to more contaminants. And that contaminant, when we're mainly talking about coal, is going to be sulfur, because we know that burning coal is going to create sulfur dioxide, which then mixes with H2O in the atmosphere, which comes down as sulfuric acid, which is a principal component of acid deposition. You can pause that, digest that, understand that acid deposition is a recurring theme. Acid rain can kill foliage. That means kill plants. It can kill forests. It can kill plants. It can also. Okay, so hopefully you know the difference between that. And I just had to take my headphones off. Hopefully you're getting the sound of this. All right, let's continue. So here is another picture of coal being formed from peat. Notice that I was saying vegetative matter, swampy area. After immense heat and pressure, then lignite is going to form the poorest grade of coal. Notice the color. The color is more brown, and as you get to anthracite, you get that rich black color, and it's more shiny. Um, and so, as you get heat and pressure, you're going to squeeze out all those contaminants. And so, anthracite Not only does it produce less contaminants and less sulfur in the atmosphere, but it's going to produce more heat for the volume of coal, and so it's going to burn hotter and it's going to produce a lot less smoke than, let's say, lignite. And you can think of that because it's just more concentrated. Okay, it's basically more pressurized, and it's more valuable because it takes more time and more pressure to form. Okay. Okay, so how can we get coal? There's a couple methods of obtaining coal. Uh, and we can do surface mining, and that's going to basically, at the surface. We talked a lot about that so far. And at the surface, we're going to potentially expose a lot of coal with the sulfur. And when rain drips down into the gank and all the waste material, the overburden, this could lead to what we call acid mine and drainage. Okay. Another thing that we could do is we could dig a hole right through a mountain, and this is going to be called drift mining. And we could also sometimes just dig a hole, and here is a shaft. All right, and we could try to dig some of this coal out, and yet again, another. This is going to be a subsurface method of digging for coal. Who would want to dig in and go in the ground and potentially get trapped? I think I was just reading an article where somebody is trapped, and I could just imagine. I feel trapped here in the Dominican Republic, and imagine being trapped in the ground. I get so hungry at particular times. I could just imagine it would be, oh my gosh, I don't know what I would do. So blessings to people who are trapped in the ground if they're doing any mining operations right now. Okay. So, how is natural gas obtained? Okay. Say this word fracking, 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 also known as hydraulic fracturing right now. And over the last 10 years, this technology has really exploded, particularly in the United States. Some people say that there is a Saudi Arabia of natural gas. Not too far away from us, Pennsylvania, particularly, there is basically they have found so much natural gas. I think this has influenced the markets on oil and petroleum because a lot of the power plants no necessarily might not necessarily need petroleum products. They could now use natural gas instead. And so if you were our oil prices were getting kind of crazy. I remember Superstorm Sandy. I think it was close to $4 to $5 a gallon, and then they dropped, and now they're climbing back up again. But I do think that one of the technologies that is influencing the prices of oil is the natural gas market. Now, natural gas, aka methane, same thing, chemical formula CH4, is going to be typically found where there is coal, or there was once coal, and then now there's natural gas. Sometimes it's trapped in rocks. What does that mean? Think of like a rock that has a lot of holes in it, and there's gases trapped in it. But these are boulders, huge, ginormous boulders with a bunch of little cracks in them, and the organic material has decomposed inside these cracks, and so now there's just a lot of these gases stored there. So hydraulic fracturing is going to be a technology where you're going to dig a hole into the ground, and then you're going to pretty much add these fluids that are going to cause these rocks to explode. Release this gas. This gas is now going to get funneled up. You're going to try to trap this gas, and now you can transport it to where you're going to put it. The issue with hydraulic fracturing is, like I said before, you're putting hardcore chemicals into the ground. When you put hardcore chemicals into the ground, if there is a water source around that area, if there's groundwater, which is typically going to be groundwater wherever there's porous stuff, you could potentially poison that groundwater. And then if you imagine doing that to the Ogallala Aquifer, you could basically destroy our groundwater supply, which would be a huge bad thing. So there is a lot of negative stigmas with hydraulic fracturing, and how do we obtain it and how do we do it properly. And that has largely to do with water contamination. It can happen at the surface, it can happen in the ground. In the groundwater, it's almost impossible to clean. How can you clean groundwater? And the surface, you could pump it somewhere, but all the wildlife and the ecology or the ecosystems are going to be destroyed if you take some of these chemicals and now you put it on the surface. So, in a nutshell, watch this video so you could see how we obtain our natural gas by hydraulic fracturing. We put hardcore chemicals into the ground. They cause these rocks to explode, and now the methane is going to come back up. We trap this methane and we could ship it off somewhere. All right. The cons here is methane can escape. It's a gas and it's in the ground. So if it escapes, now we have a greenhouse gas, GHG, with a potential greater than one, greenhouse potential, GHP, greater than one, that's going to influence the greenhouse effect, thus global warming. That's number one. Methane could also get in water, tap water, surface water, and groundwater. I've seen a video. I think it's called Gasland or something like that. And and you could YouTube this. There was a gentleman, and they typically get well water, and so it's groundwater. Their groundwater was so polluted that when they turned on their faucet, they could actually put their faucet on fire. Now that's crazy, but it did happen. And I'm not saying that we can't use natural gas, but our technologies need to be developed, and there has to be safeguards to protect our waters because water is definitely more valuable than that value than that energy source. I think we could use other energy sources. So I said a lot there. Let's try to summarize that and try to make it a little more simple. So natural gas is in the ground, stuck in rocks. We pour chemicals down, cause these rocks to explode. The gas comes out. We trap this gas, and then we could use it. Sometimes, though, the chemicals that we put in the ground, we're actually supposed to suck those chemicals back up. Sometimes those residues get left in the water. When we suck those chemicals back up, let's say when we're done getting all the natural gas, we put them on a surface area. We call it surface impoundment. We make an artificial pool, and we put the contaminants, or the leftover material, and we allow it to evaporate. So H2O is going to evaporate, so it condenses. That's what we're supposed to do. Sometimes animals drink that water while it's evaporating, or drink that. They call it brine, BRINE, or fracturing brine, and that could also destroy that ecosystem. So sometimes animals die, they lose their hair, and things like that. They lose their teeth. And it's a sad situation. So there are some cons associated with fracturing. Of course, we need an energy source. If we're going to say any pros, natural gas produces a lot less. Still produces carbon dioxide. Coal produces carbon dioxide. Petroleum produces carbon dioxide. But we're talking about, when I say contaminants, typically we're talking about sulfur dioxide. Doesn't hardly produces any sulfur dioxide in comparison to coal and natural gas, or petroleum products. All right. Let's continue. We'll try to do one more slide. All right. And so, like I was saying before, please try to go back in the presentation, watch this film. It's worth it. It's very important to understand this stuff. I was speaking to his teacher. He lives, I think he has a house in Pennsylvania. He's a hunter. He has a beard, really nice beard. It's not Heaney. It's another teacher. I'm having a brain fart right now. But he was telling me, I think he asked me, and he was like, "Yo, Rick, these people are asking me if they could dig or have some rights to the property that I own, so they can do some hydraulic fracturing." And it, here's the sales pitch. Hey, we're going to pay you, and we're going to dig a hole in your property in your 100 acres that you're not even using. So we're just going to give you money, and you don't have to do nothing, and we're going to leave everything just the way it is. That's how they'll come get you. You're thinking, well, money's nice. And you're not going to destroy the ecosystem? No, we're not going to destroy the ecosystem. I'll tell you, probably 50% of the people in Pennsylvania are saying, go ahead, do it. Um, and I don't know. I don't know. But I do know there are situations when that place could get polluted. At this particular point, there haven't been I haven't read any case studies, but it would be interesting to check to see if there have been any case studies of accidents that have been caused by hydraulic fracturing in Pennsylvania. That movie Gasland is something that we should probably take a look at. I think it does have some scenes from Pennsylvania, but if he was asking me, I'd say if you don't need that money, don't do it. But some people need the money, so what are we gonna do? What are we gonna do? All right, what are we gonna do? All right. So anyhow, we talked a lot about hydraulic fracturing. Watch this video. It's important because we get our water from Pennsylvania. Okay, we get a lot of our water from Pennsylvania. A lot of that Poland Springs not coming from Poland, man. It's coming from Pennsylvania. So you need to understand where our water is coming from. We do get our water from New Jersey. The stuff from coming from our tap comes from our reserves in New Jersey. But if we were looking at the underground aquifer, it does part of Jersey's aquifer groundwater is also in Pennsylvania. So it's something that we need to consider, even because it's going to affect us as well. All right. Finally, by shaking the ground up with those high fracking fluids, sometimes there are earthquakes that can be caused as well. They're not going to be super huge, ginormous earthquakes, but the ground does shake. I remember 2 years ago, I think there was a small earthquake. Some people said that that was caused by the hydraulic fracturing that's occurring in Pennsylvania. All right, you guys are amazing, and I hope you heard all this lecture, and I'll talk to you and see you soon.